guys, so I've picked out a linear programming problem for us to work through today. These are the problems where you have to write 2 or 3 different inequalities, and then you have to graph those, and you have to find where they crisscross and the corner points of those, and plug them into what's called an objective function to find a maximum or a minimum. You'll know these problems if you've ever had them in class. So here is how I begin these types of problems. You should take a minute to read through the whole paragraph, so you can pause this if you want and read through it. But the first thing I do after that is I reread the very final sentence, which says, find how many acres of each crop you should plant to maximize your profit. That's telling me to find how many acres of each crop. So that is telling me what my variables are, which would be the crops. So at the beginning of the problem, it had mentioned lettuce and peas. So those are our 2 crops. And what I do with these problems to keep everything really organized is I make a chart. And at the top of the chart, I always put the variables. So we have lettuce, and we have peas, and then I always put the word total into the last column like this. And then I make a few extra rows. So we're going to have to fill in some numbers as we go along. Okay. And then I start looking through, rereading from the beginning of the problem for any numbers that they tell me. So the first number I see is that says you have 100 acres of land to grow lettuce and peas. Well, that's a total. I have 100 acres total of land. So I'm going to put the 100 into my first total. Now, if I keep reading, the next number I come across is in the sentence where it says lettuce costs $120 per acre to plant. That number, that dollar amount, is a cost. So over to the side here, I'm going to write cost and fill in that that's $120 of cost for the lettuce. And if I keep reading, I notice that the next thing it says is that lettuce makes a profit of $30 per acre. So that needs to be another new line that I'll call profit. And that's for lettuce, and it's 30 per acre. And if I keep reading, go back to highlighting with the green here, it says peas cost $200 per acre. And that's another cost amount. So in the cost line for the peas, I'm going to fill in 200. And then the peas make a profit of $60 per acre. So in the profit line for peas, I'm going to fill in with the number 60. Then I get to this final number that they're mentioning, which says the most you can invest is $15,000. Well, if you're investing in something, it's costing you money. So the $15,000 is the total for the cost line. So the line that I called cost, $15,000 goes into that total. And that first line I never labeled. It was the acres of land that you had to grow. So we could just write like, just put acres right there. And some of the boxes are blank, and that's totally fine. Let me write above the lettuce. The lettuce I'm going to make my X, and the peas are going to be my Y. Those are my 2 variables. All right, so now the next thing is to take each row and write an equation out of it. So this very first row, where it says acres and there's nothing filled into those 2 boxes, but the total is 100, well, those 2 boxes are the X and Y. So what I would be saying is that X plus Y has to stay less than or equal to 100. Because we can't plant more than 100 acres of crops. Then I just take the next row, which was called cost. It's all of those numbers, and I make an inequality out of that row, which would be 120x plus 200y, and that has to stay less than or equal to 15,000, because we're not allowed to spend more than 15,000 to plant the crops. And then this final row was for profit. It had numbers, but it didn't have a total. And that's because that's our objective function, but but we still write kind of the same thing. We say 30x plus 60y. And what we can do there, since we don't have a total, is just say, well, that equals our profit. Just say it equals the word profit. The other thing, too, is that with these linear programming problems, it usually doesn't make sense to have any negative numbers. So you can also say, okay, well, x has to stay greater than or equal to 0, and y also has to stay greater than or equal to 0. And that means that we could just make a graph in the first quadrant. So I'm going to change my x and y axis here real quick. Okay, so now what we're going to do is graph the inequalities. Well, x greater than or equal to 0 just means that you stay from, like, the y-axis this direction. And y greater than or equal to 0 means that you stay from the x-axis, you stay above it. So see, I've already kind of incorporated that into my graph because that would make everything be in the first quadrant. So I'm going to get rid of that highlighting. All right, so those two are taken care of. With the other two inequalities, we're going to get y alone so that we can graph them more easily. So if I do x plus y is less than or equal to 100, I would subtract x from both sides. So I get negative x plus 100. Okay. Let's do the same thing with this second equation. I'm going to get y alone, so I'll subtract 120x both sides. So now I have 200y is less than or equal to negative 120x plus 15,000. Then divide everything by 200. So I will get y is less than or equal, and you can do some reducing in your calculators. This is going to be negative 3/5 x plus 75. Those are the two equations that we need to graph. My y-intercepts are 75 and 100, so I think what I'll do is count by tens. Okay, so I'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then I'm going to start by graphing this one. So my first y-intercept is 100, so that's there. And then it's the slope of negative 1, so I'll have to count down 1 over 1, down 1 over 1. And I usually just keep doing that until I meet up with the x-axis, because these graphs need to be really precise. So there's that line. And the other line has a y-intercept of 75. So that'll be like right there. And the slope of that line, I'm doing this green one right now. So the y-intercept was 75. Then I'll count down 3 over 5. 1, 2, 3, 4, 5. Down 3 over 1, 2, 3, 4, 5. That's probably good. And then that'll be this line. So it's kind of hard to tell where the two lines are crossing, but we can do some work to figure that out. Now the shading for each line, both lines were less than or equal to. So that means that the shading would end up being all down here. Okay, now what that does is creates vertices. So we have a vertex here. That point I already know what it was. It was 0, 75. Here's another vertice. 6, 7, 8, 9. That ended up, that one was at 10, 0. The origin is a vertex. That usually won't give you your maximum, but let's write it down anyway. And then the tricky one is we have to figure out that point right there, where the two lines are crossing. What you could do to figure that out is set the two lines equal and just solve by hand. So the yellow line, which was negative x plus 100, equal to the green line, which was negative 3/5 x plus 75. And then we could just solve that for x. I think what I will do is add this x. There's a lot of fractions, but don't let those scare you. So this will be 2/5 x plus 75 equals 100. How about if we subtract 75 over? So that gives us 25 equals 2/5 x. And then you can multiply both sides by 5/2. So that's going to give us x equals 125 over 2, which that equals 60. Sorry about that. That equals 62.5. Okay, and then we can plug that back into either line. Maybe I'll just do the yellow one. Y equals negative x, so negative 62.5 plus 100. So that y would equal 37.5. Okay, so those are the coordinates at that point. 62.5, comma, 37.5. Okay, now we're finally on the last step. What we do is we plug in all of those corner points into our profit equation for each x and each y. So here, I'll kind of color code it here. Let's make our first point be the 0, 75. So I'm going to plug in 0 for x, so 30 times 0, plus 60 times y, so 60 times 75, and that'll give us that profit. You can use a calculator to figure that out. We'll go back and figure them all out. Then, why don't we plug in 10, 0 next? So that's going to be plugging in 30 times 10 plus 60 times 0. And that'll give us that profit. Then we could plug in this crazy point with the decimals. So that'll be 30 times 62.5 plus 60 times 37.5. That'll give us that profit. And we can plug in 0, 0. It's definitely not going to give you the maximum profit, but there's 0, 0. So 30 times 0 plus 60. 60 times 0. We know that's going to equal 0. So now just punch these into your calculator. And I just did that, and I got 4,500 for this first one. And I got 300 for this one. And then for this last one, I got 4,125. The largest answer is right here, 4,500, which means that when I planted 0 crops of lettuce and 75 acres of peas, I got my largest profit. So the amount of crops that you need to plant to achieve the maximum profit would be 0 acres of lettuce and 75 acres of peas. And that is your final answer. And the profit that you would make by doing that would be $4,500.